Hello, everyone. You are welcome to today's lesson. And today's lesson, we are going to bring down the curtains on the topic permutations and combination. Okay, in our previous lesson, we started looking at solution to some past questions and equally likely exams questions. Okay, so we solved the question up to question 8 or so. Now we are going to look at what question 9. The set of questions that we are going to look at here, okay, will be a little different from what we've seen so far. Here I am going to explain, okay, based on the foundation of what permutation, the foundation of combination, if the question has to do with what combination. So we are not going to use formulas per se. So foundation basically will be the traditional way of dealing with it. It's a traditional way that will help us formulate, okay, a particular concept or a formula, okay, for you to make your work very easy. So indirectly, you know where the formulas are coming from. We are not going to use formulas. And questions like this, okay, going your basic way, your traditional way, your, what do you call, first principle way, be the best way to go rather than the formula. So we are not going to make use of all the formulas so we'll shelve the formulas for now and do a bit of analysis, okay, to look at how best to deal with questions of this nature. So let's go. All right. Okay, so let's look at the first question. Okay, a company plans to assign identification numbers, ID numbers, to 8 employees. Each identification number is to consist of 4 digits from 0 to 9, inclusive. So underline this. This is very critical. 0 to 9 inclusive. So 0 inclusive, 9 inclusive, sort of, or 9 inclusive because inclusive, okay. So now let's see, except that the first digit cannot be 0. So you can see another constraint here. I hope you are with me, my professors.
Yes, please.
Okay, so you can see a constraint. Okay, how many? And you can see that here again, I should have underlined this 4 digits. Okay, your ID must contain 4 digits. How many different, okay, identification numbers are possible? How many different identification numbers are possible? So here, this is all that you need to do. Okay, so as usual solution, if for nothing at all, you know that you have to start with the question 9. Okay, so with questions of this nature, just as I told you in the previous meeting, okay, your solving skills is going to be tested. This question is basically going to test your solving skill in terms of, well, I mean, permutation question solving skill, combination question solving skill, basically. Okay, so what you need to do is that anytime the question is given, try as much as possible to translate the question to the best of your understanding. So bring the question home. And okay, more or less, try and visualize the nature of the question and underline anything that you can infer from the question. Sometimes some of the information or the inferences that you can make, okay, will be indirect. Okay, and as we continue, you know, I always select my questions to touch on all that you need to know. So as and when, okay, you will need a particular indirect information, okay, how to fish out that information, I will tell you. Okay, and after that, okay, what is important is you need to know of your constraints. But first of all, you have to set what we call your objective equation. Your objective equation, and that is what I'm going to do. You know, there's a very first question, so my presentation will not be that ideal. Okay, I will write more. So please listen and listen attentively at this point. Now you know we want for a 4 digit ID. So it means I have 4 places to fill. Am I right?
Yes, please.
Okay. Now, obviously, you know that from 0 up to 9, okay, how many digits do you have in all?
10.
10. Please, do you agree?
Yes. Yes.
So it means your total number of digits, let me use D. The number of D is your rough work. okay, you know is what? Is 10. You have 10. Okay, now let's see what we are going to do. Okay, I am going to ask you a very vital question. Maybe it will come later or very soon. Okay, than later. Okay, so now let's see. Okay, we are told, we are trying to break the question down. Objective function, okay, because we are looking for, okay, 4-digit identification number. Okay, now our objective function gone, and we know that we are going to fill these places with what? The numbers available from 0 up to what? Up to 9. Okay, so let's go. All right, there is a condition that your first digit cannot be 0. Is that not it?
Yes, please.
So it means if I want to fill up this first space, okay, the numbers that will be available for me to fill the first space will be, mention the digits.
1,
1, 2, up to 9. Is that not it?
yeah,
Up to 9. So how many digits, okay, can take this place, can assume this place?
9.
9. So you write 9 here. Is my point well made? Originally you had 10, but because of the condition, okay, you cannot, okay, have 10 digits here because 0 cannot take this place. So your digits, any of them apart from 0 can be here. Is my point well made?
Yes.
Okay, now let's go and fill up the second position or the second place, not position per se. Okay, the second slot. Now you can see that, okay, if I'm going to fill the second slot, take note, if I'm going to fill the second slot, how many digits can take the second slot? Of our digits, how many of them? Tell me the digits, or let me ask, the digits that can assume this. Mention those digits.
Yeah, 8.
8 digits.
10.
Okay, somebody said 8, somebody said 9, and 10, right?
Yes, please.
Very good. Hey, so this is, I intentionally didn't ask that question. Okay, so good. All right, now I know how to explain. Okay, because you equally have same, okay, issues. Okay, so now let's see. If you have this, remember, this is your first digit, which you were told that cannot assume the number 0. Were you told that the second digit, the third digit, the fourth, cannot assume 0?
No, please.
No. So it means the 0, which initially was not available for selection for the first, okay, slot, is now available. True or false?
True.
Did I hear false? Hello, did I hear false?
Yes.
Okay, all right. So this is, then it means you still don't get it. Okay, we said, okay, that your identification number, that's the 4-digit identification number that you want to form. Okay, you form it in such a way that the first digit cannot be 0. But the first digit cannot be 0. Doesn't mean the second cannot be 0, the third cannot be 0, the fourth. It's only the restriction for the 0 is for your first digit. The rest, there is no restriction. So the rest, 0 can be here, 0 can be here, 0 can be here. Is that clear?
Yes, please.
Okay, so it means for my second, okay, position that I have here, my second slot, I know that I still have 0 up to 9 available to select. Is that clear?
Yes, please.
Okay, and please take note. Some of you said 8, some said 10. 10, you are right because of what I've said. Okay, and okay, some of you said 9. Those who said 10, I want one of you to explain why you should have 10 digits, not 9. Or not even 8.
Fair.
Yes, okay, go ahead.
Okay, since the restriction was already on the was only on the first digit, which is the digit not be 0. So the second slot can be from 0 to 9 inclusive. So we had the number of digits were 10. So that is why we are saying 10 should be 10 digits can occupy the second slot.
Okay, very good. Okay, I'm tempted to hold on with something. The next question, then I'll bring in that one. Immediately I answer this question, the next question will be answered. Okay, so I'll hold on. Very good explanation. So this is going to give us 10. In fact, just for the simple reason that, okay, let me answer. Okay, so this will be 10. Okay, it wasn't 9 because in the question, we don't have sufficient information to say that repetition of the digits is not allowed. Should I come again?
Please come again.
Okay, usually, okay, Prof. Yaba, your hand is up.
But the last sentence is how many different identification numbers.
Very
So
good.
the numbers are supposed to be distinct.
Okay, the numbers are not, are you talking about the numbers that identification numbers must be distinct, but not the individual digits, okay, that we are saying that must be distinct. Is the number. Is that clear? So let's see, let's bring it down. Assuming I have 1 and 2, I have these two, and I want to form more or less a two, what do you call it, digit identification number. If I have 2, 2, okay, 1, 1, okay, then I can also have what, 2, 1, is that not it?
Yes, please.
Okay, are these numbers that we have here, are they different numbers or not? So you can see that here, this is talking about different identification numbers. The question didn't say different digits. I hope you get my point. If the question emphasizes on different digits, then it means this 2 must be taken out. So in that case, it means indirectly repetition is not allowed. Is my point well made? Prof. Yaba, do you get the point?
Yes,
You
please.
get the point? So you have to be very critical. Okay, but that's why I said what you can infer. So usually look for, okay, repetition, whether repetition is allowed or repetition is not allowed. Okay, if repetition is what do you call it? Not allowed, or I should say, if yes, if repetition is not allowed, you will be told in the question, either directly or indirectly. So very soon you will know, okay, the indirect situation. Or so maybe the direct one you see where repetition is not allowed or repetition of digits not possible. Okay, so we can state that in that case, you can see that it is obvious. You are told, okay, it is direct. But with this one, we don't have any information, okay, from this question, whether direct or indirect, okay, that repetition of digits is not allowed. So it means repetition is allowed. Okay, and here, this ordinarily could have been, but for this condition, this could have been 10, 10, 10, 10. Is that not it?
Yes,
But because
please.
the first one we were told there was another constraint, the constraint was on one of your digits 0. Okay, 0 will not be available, so you only have 9. However, going forward, 0 will now be available together with all your other digits. So in this case, the next one will also be 10. The next one, the last one will also be 10. All correct.
Yes, please.
You had 4 positions to fill, okay, which you have. Okay, so once you fill, these are independent events. So the overall result will be multiplication. That's all. So in this case, this is how you are going to proceed. Straight away, you can go and write your number. Okay, I can write maybe giving digits 0 to 9, what have you, because that is what is important. Okay, remember your overall inclusive. So 0 to 9 inclusive. Okay, so giving, let me write. Okay, otherwise what I'm going to write will not be so. Okay, digits. Okay, so now I'm going to clear that. I use that one to explain, and it's going to interfere with my rough work. Usually you have more room for the rough work, so you always push your work to the side. Okay, so that I'm talking about your rough work, it doesn't interfere with your main work. I can obviously see that mine is going to interfere. I've explained, so I think I can clear it. Okay, so we'll just make use of that information. All right, so in this case, digits, okay, we know we'll be giving digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, okay, 9. Okay, so now I can come and write, therefore, number of ways. and the 4 digits you underline. So that's what will help you do your rough work. Okay, the rough work that give us, okay, 9, 10, 10, 10. So we are going to multiply. So that will give us, this will be equal to 9 times what? 10 times what? 10, and times 10. Okay, so this in effect will give us what? 9, okay, 0, 0, 0, and you attach your ways. Afa?
Yes, please.
Okay, so don't worry, if you are not up there, you will be there very soon. So if this happens to be your rough work, you strike it out. Okay, so the next one, maybe probably I will handle it, okay, maturely. So we are going to move on to question 10. So you can see that this one, no formula, we just analyzed, picture the situation, visualize the situation, then we apply the constraints that we have on our, okay, objects. As simple as that. So let's look at question 10. We are going to read this one carefully. Okay, a company plans to assign identification numbers to its employees. So similar statement. Each identification number is to consist of 4 different digits. Underline that, that's a constraint. Okay, from 0 to 9 inclusive. Oh, okay, so now what do we have? Except that the first digit cannot be 0. So similar to what we have, the only that there is another information that you have to be very critical, okay, of how many different identification numbers are possible. Okay, so now let's see. All right, if you look at what you have here, you can see that, okay, let me underline whatever I underline here too, because everything that I underline here will be here. Then inclusive, 9 inclusive, okay, will be there. So indirectly, that is also what underlined. Okay, you can see all that I have underlined. There is a variation in one of them, this and that. Can you see that?
Yes, please.
Okay, so because here you are told that 4 different digits, indirectly, okay, the question is trying to tell you that you don't repeat digits. I hope you get my point. It's trying to tell you that repetition of digits is not allowed. So that's why I said when repetition is not allowed, the question directly or indirectly will tell you. So this is an indirect way of telling you that repetition is not allowed because you need to get different digits, 4 different digits, because immediately I repeat, I will no longer have what? Different digits. Is that clear?
Yes.
So take your time. Now I've told you, you know, the way I select my questions, okay, to take care of all possible situations. So now you know, anytime you see 4 different digits, different digits, different digits, you can see that this one is different, okay, numbers, not different digits. So whatever you have here, be in terms of the different numbers. So the numbers will be different even if you, okay, repeat. However, your digits will not be different when you repeat. Is that clear? So with this one, repetition is not allowed. So all that I'm going to do is, okay, I know. Okay, so therefore, so question number 10. Okay, again, if you want to extract, giving, okay, so let's go. Here we have the same number of digits. So digits, you are very particular about that. Okay, digits, so you go, you can write 0 to 9 inclusive, instead of writing everything inclusive. The same thing, this time around, I'm handling it maturely. Okay, so I've written less instead of writing less. Okay, so now what am I supposed to do? Therefore, number of ways, always, we know that's what we are looking for, number of ways. And this will be equal to come and do your rough work. If you like, if you are matured, even your rough work will be seen here. I have 4 spaces, is that not it? So the first space, what can possibly be there is what I'm going to write, but I will advise you equally do same. So 1, 2, 3, 4. Again, we have 4 spaces to fill. The first one, we can choose from 0 up to 9, so 10 digits. However, because the condition, there is another restriction. Okay, constraints here. on the 0. First digit cannot be 0. So you have how many digits? 9. Am I right?
Yes.
Okay. Now, though you have 9 here, this position will be occupied by only one number. Is that not it?
Yes, please.
Okay, only that one number could be 1, 2, up to 9. That number, but it will be only one number. The 9 that you have here doesn't mean you have 9 numbers, okay, here. It is only one. Only that you have 9 ways of, filling this space. You get it?
Yes, please.
Okay, then let's go to the second one. Now, if you are moving on to the second one, you can see that if this space, was, he said between 1 and 10, one of them will be here. So if this space was occupied by 1, it means 1 will not be available for selection for my second, space. Is that clear? Because repetition is not allowed. You get the point? However, you can see that this time round 0 is available for selection. You get the point? So it means you will have 0, 1 is not available, you get 2 up to what? Up to 9. So you still have 9, to put here. Is that clear?
Yes, please.
Please, who wants me to come again?
Please, me.
Okay, so don't wait for this question. All right. Okay, so where should I? Is it the first one? You get it, right?
Yes, please. The
Okay,
second one.
is the second one. So you agree just from this statement, just from this, that your digits must be different. Is that not it? You get it?
Yes, please.
Okay, so you know that this space, though you have 9 ways of filling this space will be occupied by only one of the digits from what? 1 up to 9. Is that not it? So it means
Yes,
if it was 1 that is there, the next one, I cannot use 1 because repetition is not allowed. You get it?
Yes, please.
Okay, but 1 will not be available, but you can see that this time around 0 will be available. Is that not it?
Yes, please.
Okay, so if 0 is available, and from 0 up to 9, you have how many digits? 10 digits, and 1 is not available. It means that you still have what? 9 to fill this. Okay, ordinarily it would have been 8, but because now 0 is equally admissible, the 0 will come in and make it 9. Is the explanation okay?
Yes, please.
Okay, good. So it will be then the next one. You can see that with this one, as you move, it will be reducing because you cannot repeat. You get the point? So this position was filled by 0. Okay, I've told you that you assume maybe this 1 was here. If 1 was here, then it will be 0, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so assuming maybe 2 was here. If I'm moving, you can see that this time around 2 will not be available. So it will reduce my number of digits by 1. Is that clear?
Yes, please.
Okay, so it will give me 8. And the next one to my number of digits will be, because 1 digit will be here, which I cannot repeat. So the next one will also give me what? 7. All correct?
Yes.
Yes.
Okay, so it means that is going to give me 9 times what? 9 times what? 8 times 7. All correct?
Yes, please.
All right, sure. So I'm waiting for your calculator value.
4536. 4536.
4536. Okay, ways. Safa.
Yes.
We'll do more anyway. Okay, we'll do more. Okay, the technicalities, everything, will be brought to bear. Okay, all right. Prof. Nunley.
So please, I want to get the reason why we are multiplying, not adding.
Okay, so remember I said you are dealing with independent events. Okay, and usually this is what you do. You look for your spaces. if your spaces that you have here, you are supposed to fill all of them. Okay, that's how we explain. If you are supposed to fill all of them, then you should know that you are dealing with what? Multiplication. But if you are not filling all of them, then you are not dealing with multiplication.
Okay.
Okay, but we always say that they will be independent. So once it's independent, it's 9 and this, okay, this position and this position and this position and this position must be filled. Okay, so you multiply because of the end.
Okay.
All right. Okay. So if well understood, then we can move on to the next set of questions. Okay, you are doing well if indeed you are not hiding, okay, your issues. All right. So let's move on to the next, okay, set of questions. Okay, all right. So I think from here, I am going to pause so that you have your water break. All right. So that when you come back, then we'll look at the continuation of that. Okay. Okay, so welcome back from the water break. Okay, so quickly, let's look at our next set of questions. Okay, so question number 11. How many ways can we form a 3-letter password? So 3-letter password. Okay, using the letters from the set. Okay, so using the following letters, A, B, C, D, F, they are distinct letters, such that the last letter is a vowel. So there is a constraint on the last letter. So this is critical. Is that clear?
Yes, sir.
Great. Okay, so now that we have underlined the salient parts, we have to go and look at what our objective, okay, equation. And the objective equation, this is what we are going to do, a function. Okay, we are looking at 3, okay, letter, okay, password. So 3 spaces to be filled. All correct?
Yes, sir.
Okay, so again, as usual, giving, so solution, question number 11, just extract. What is important will be your pool, okay, meaning your total set. So you've been given the sets A, B, okay, C, D, E, okay, then F. This is what we have. Okay, now, first of all, remember, I've told you every question, okay, of this nature, ask yourself this vital question: is repetition allowed? Okay, and I've told you if repetition is not allowed, you will be told directly or indirectly. So if directly or indirectly you don't see this constraint that repetition is not allowed, then it means you are dealing with what? Repetition was allowed. All correct. Is my point well made, my professors?
Yes, please.
Okay, so now let's go and look at how best we can deal with it. Is repetition allowed or not allowed? Repetition allowed or not allowed?
Allowed.
Allowed. Very good. All right. So if you saw, okay, there may be 3 okay, different letter password, then you know that repetition is not allowed. Is that clear?
Yes, sir.
Okay, very good. So now I know you are matured. You know all the tricks, so you will never fall a victim. Okay, so let's go. So our objective, so if for nothing at all, you know you come and write. Let's write our, therefore, the number of ways. Okay, as for this one, it's automatic. Okay, so far we know. Okay, will be equal to. So if you mature, I can straight away bring this one here and do it. Okay, multiplication, this. You can do that too. Let me equally encourage you to do that. You can also do this. You know you'll be multiplying, so you can do this. Is that okay? And fill the spaces. You can. Okay, so let's do that. Okay, this being our 3rd question, so we can handle it a little more maturely. So let's go. All right, so with this one, my advice is, okay, and I repeat, my advice is go and fix, okay, where you have more constraints. So in this case, I have more constraints on what? On the last letter, okay, which must be, okay, a vowel. So this position is where I have more constraint, true or false?
True.
True. So I'm going to fix that first. Okay, before you fix that, please, you need to determine the letters here, which will be your vowels or which are your vowels. So the vowels here, how many do we have?
Two.
A and E, is that not it?
Yes, sir.
Okay, so it means this last, okay, position that you have here, okay, the last space that you have here for your last letter that you have there, this, okay, how many ways can we fill this space?
2.
2. It's either we put A here or E here. So it means this will be 2, squiggly. Is that clear?
Yes, please.
Okay, very good. You have 2 possible ways, but you know that in your mind, you know that it is only one of them that is here, either A or E. Is that not it?
Yes.
Okay, the 2 of them, okay, are not there at the same time. Okay, so now we are going to fill the other 2 spaces. So I will come here. All right. Repetition is allowed, is that not it?
Yes,
So
sir.
if repetition is allowed, it means if this is A, okay, this can still start with A, is that not it?
Yes, sir.
Okay, and it can also start, if this is E, it can still start with E. So this position can take any of the letters that we have here, true or false?
True.
True. So how many letters do we have there? 6. So it means we have 6 ways of filling this. It could be A, B, C, D, E, F. So that is going to give us what? 6. Repetition is allowed. So this one will also be what? Okay, 6 as well. Should I come again? No, my point is well made. It's getting technical, right? But don't worry, if you pay attention and you condition your mind that you get it, you get it. And if you ask questions too when you have issues, okay, it will better shape what your understanding as well. Okay, all right. So at this point, we are in a comfortable lead. So I'm waiting for the answer. That is 6 times 2. Okay, you are going to get what?
22.
So it will be 72 ways. Safa. Okay, assuming, okay, let me ask, assuming repetition was not allowed, okay, what would that be? I need how you, the values that you place here, okay, in the 3 spaces. Okay, I don't need the total. Once you get the values here, ask for the total, it's just calculator work. Okay. If repetition is not allowed, so maybe if the question was 3 different letter password. Okay, Prof. Ella, let's go.
I want to try.
Yeah, go ahead.
So the first one will be 4
No, you are starting from where?
from the first letter.
Okay, remember I told you start from here. It's very critical. Where
I'll
you
start
have
from
more
the second.
control.
Okay.
Yeah.
The second one will be 2.
No, not the second one. The last one. That's
Hey,
where
the
you
last
have
one will be 2.
will be 2. Okay.
Yes, please. Then the next one will be 4
Will be 4. Why?
because no repetition. So meaning the next value, there shouldn't be the vowel shouldn't be there. I don't know if you get what I'm saying.
Okay, so what if this vowel was E?
Okay, 5. Sorry, 5. 5.
You
I'm
get
sorry.
it.
Yes.
You get it. You know,
5.
that's why I said ask yourself. You can see 2 there, but in actual fact, there is only one number, one
Only
okay
one.
letter
Yeah.
here. So it is, if it is A that you can't repeat. Okay, but
Yes,
you can
please.
bring the E. So this will give you, okay, 5, and the next one will be
The next one will be 4.
4. Okay, so it will multiply as simple as like that. Alpha. You get it. Okay, you almost slipped. All right, okay. Thank you very much, okay, Prof. Ella. All right, okay, so now on that case, okay, we are going to look at this. Okay, and you will help me deal with this because I believe that I have equipped you well enough to handle this one. It's very similar to this. Okay, only that the first part, the first statement is where you have, okay, the difference. So in how many ways can we form a 4-letter password using the letters from the set, okay, so the same set, such that the last letter is a vowel? So again, last letter, a vowel. Okay, then we are looking at a 4-letter word, not distinct letters. Okay, so now what do? We go and write, okay, the question number, okay, giving, okay, your sets A, B, C, D, E, F. Okay. You can even choose not to extract and straight away start with therefore your number of ways. Okay, number of ways. Okay, and go and do your rough work if possible. So with this one, we are matured. How many positions are we filling? Then I will call you to help me fill the positions. Okay, so how many positions? 4, right? So it will be the first, okay, times the second, times the third, and times the fourth what? Okay, letter, which is the last letter. All correct. Okay, so now, okay, your hand is still up. Oh, it's a new one. I guess it's the old one. Okay, so someone should help me deal with, okay, the question 12 before I start calling you at random. Okay, I will start calling you at random. If you don't want to volunteer, you don't have time. Okay, so let's see. Okay, Prof. Kennedy, let's go. Prof. Ken, are you there? Let's go. Okay, you said you have an issue with your audio and it's still not fixed. Okay, Prof. Ajua Asante, let's go. Okay, how many ways can we fill this space? So we are going to fill the spaces individually. And you tell me why. Your value that you give, you explain why that should be the value that we put there. I'm waiting. Prof. Ajua Asante, are you there? You respond or I give you a yellow card. Okay, Prof. Abba, so Ajua Asante, yellow card.
Yes, sir.
The last letter, how many ways can we form that?
Sir, please 2.
2. Okay, why 2?
Because there are only 2 vowels in the set
so
of
2 vowels. So it will be either A or E. That must be here. So 2. Very good. Oops. Okay. All right. So now let's see. Ajua Asante, are you there? All right. Okay. You are compelling me to remove you. All right. Okay. So let me see. Ken, you've not sent me a message that you have any issues. I don't know whether you have solved that issue. Okay, if not, please send me a message via chat. Okay, Ajua Asante, same to you. Okay, Prof. Asib, let's go. Okay, the first one, once you come, then you come and start from your usual, okay, one. Your first one, how many, okay, letters can we or can take the place here? So what will be the number that we are supposed to put here? Hello, Prof. Asib, are you there? Prof. Asib, you are disconnected. Okay, anyway, you come back. I'll definitely get you again. All right. Okay, Prof. Tusi, you can type. So type and tell me the value that will be here and attach your reason. You said you have an issue with your audio. If you don't respond, it means you are not attentive. Okay, so I'm waiting for what you type and send to me. Okay, let me wait briefly for that. Just the value and explain why that should be the value, if possible. Oh, hurry up. Otherwise, you know, I remove you. Okay, so Prof. Inshira, let's go. I've not received any chat yet. Okay, so let me remove them. Okay, Inshira, I'm waiting.
Hello.
The first one, what should be there?
Given A, B, 6, A, B, C.
No, we are feeling we've gone beyond that. It means you just joined us. We've gone, I want what should you will put here. We've gone beyond this.
As 6.
6, why 6?
Because there are 6 letters and then there's nothing saying that, but there's no restriction about the first.
There is no restriction.
Yes, about the first letter.
There is no restriction for the first letter.
Yes.
Okay, so indirectly you want to say that there is repetition, is that not it?
Yes.
Okay, there is no further. Okay, so very good. Please, do you all agree?
Yes.
Okay, so this will be
Yes.
6. Okay, Prof. Asib. Okay, I can see you've joined again. Please answer before you are removed. Okay, I'm removing all those I mentioned their names and they didn't respond. Okay, so the next one, the second letter, what should be there? Okay, Prof. Anjinchi, let's go. Prof. Anjinchi, are you there? Okay, yellow card, I'll remove you pretty soon. All right, so let's see, Prof. Ekuya, let's go. The next one, what should be there? So it means some of you are in class, but you are not. Please, can you hear me?
Yes, please.
Okay,
Yes.
so it means I'm not wrongfully removing them. Okay, so a message has come. Okay, Kuya says, okay, Anjinchi, please respond. Okay, if you have audio issues, let me know. Kuya has responded, so she is free. Okay, all right, okay, Prof. Liz, let's go.
Mr. Akman, please, 6.
6, why 6?
Because repetition is allowed.
Okay, very good. Okay, so obviously the next one will also be 6, is that not it?
Yes.
Okay, so that will be it, okay, for the solution to this question. Okay, so try and follow, you will get it. Okay, and ask questions whenever there are issues. Okay, but Anjichi, I guess you are following. If you have audio issue and you are following, fine. Okay, but at least you definitely we need to ask 1 or 2 questions. You need to, maybe you will type. Okay, all right. So when I call you, respond promptly, especially if you know you have audio issues. All right. Okay, so I think that will be it for, okay, this particular question. Okay, so now let's go to the question in what 13. Okay, question 13 is quite different. So let's write the final answer here. What would be the final answer?
432.
4,
32
32 ways. Okay, so now let's come to this. As usual, question number 13. Okay, what are we giving? Okay, our letters forming the set A, B, C, D, E, F. Okay, so now therefore number of ways. Okay, this question is a little different from, okay, what we've done. So let's look at the condition. Okay, in how many ways can we form a 3-letter or a 4-letter password using the letters from, okay, the same set, such that the last letter is a vowel? Again, the last letter is a vowel. Okay, this is key. You underline this. Very, very critical. Okay, so it means the question has introduced you to another possibility or another set of constraints that you need to look at. So you have to look at how you can form a 3-letter password, or how you can form a 4-letter password. You are not forming the two together, so separately. So you add. So in this case, you are going to get this. Your first one, which is the 3, will be this times you have 3, okay, spaces to fill, or, and that will be plus. Your next one will be 4 places. So 1, 2, 3, okay, 4. All correct?
Yes, please.
Okay, so we are going to, okay, fill. And you can see that, okay, indirectly is what we've done here that we are going to put together. Do you get my point? You know how to find the 3 ways. We've done the 3 ways where you will have vowel, okay, as your last digit. Sorry, last letter. So that will give you 2. Then it will be 6. No, okay, repetition is allowed. So 6. Okay, then this one will give you also 2. Then it will be 6. Okay, 6. Okay, 6. So in this case, we are going to get, this gave us what? The 72. Okay, plus this gave us what? 432. Okay, so in effect, we are going to get what?
504.
Okay, come again.
504.
Okay, so 5, 0, okay, 4 ways. Safa. Okay, and please take note. Here, we consider the arrangement, okay, and we realize that all our objects, in this case, were distinct. Okay, we are going to look at another situation. Okay, so I will make sure all possible situations, okay, you know how to deal with it. Okay, you can see that a lot of technicality, so you need to solve more questions before, okay, these technicalities will be part and parcel of. Okay, otherwise, by the time you realize, okay, you will forget. Okay, all right. So one of the technical topics, okay, in that, okay, is multiplication. We can put the question anyhow. Okay, give the constraint anyhow. If you are not strong, and if you are not able to get your objective function and picture the situation, okay, you will struggle, or visualize what you are dealing with, you will struggle. So question 14, okay, solution to question 14. So the digits of the number, so we've been giving, okay, the number, so giving number. Okay, now in any case, digits. Okay, so that is what we are interested in, the digits. So let me extract precisely as well. As I always tell you, you are extracting, but okay, extract precisely. So giving digits. Okay, and that will be 1, 2, 3, in the case of a number, oh, sorry, 1, 2, 2. Okay, 3, okay, 6, 7, okay, 8. So this is what we have. All right. Now, if for nothing at all, we know, hey, we could go and okay, read the question thoroughly, but we know therefore a number of ways. Okay, will be equal to. So now let's go. We said, okay, let's see the number of the digits of the number. Okay, so 1, 2, 3, 4, 5, 6, 7 can be arranged to give many different 7-digit what numbers. Okay, so obviously you know. Okay, in this case, are we talking about the digits being different or your numbers being different?
The digits being different.
The digits being different. Okay, who disagrees? Okay, all right, so let's go. Okay, so maybe along the line, I will address that. Okay, but she's okay, right anyway. So let's see, how many different 7-digit numbers can be made if, so obviously you can see that condition. Okay, this one is about, so 7-digit what numbers, different 7-digit numbers. So let's see whether indeed we have the same meaning. Different 7-digit numbers. Okay, different 7-digit numbers. All right. So this one is between you and your English. And very soon, okay, mathematicians will break down the English for you. All right. Okay, so let's see. This is what we have. You can see that in actual fact, the first one, if there is no restriction on the order of the digits, so there is no restriction. Okay, this question, okay, we should all be able to do it. Okay, you are not picking, unlike the previous, the one that we just solved today. Okay, where you are giving digits or you are giving, what do you call it, letters. And you are not selecting all of them. Here you have 1, 2, 3, 4, 5, 6, 7. So here you are forming a 7-digit. So at any point in time, you need to select all of them. Am I right?
Yes.
So you can see that this one is similar to what we know. So you don't, in fact, you don't need my inputs. So it's just like you count the number of digits. Okay, 1, 2, 3, 4, 5, 6, 7. So that will give you 7 factorial. Am I right? Then over, you can see duplicates, so 2 of them over 2 factorial. So the number of ways of arranging this digit, that's all that the question is. Should I come again or my point is well made? Is my point well made, my professors?
Yes, please.
This
Yes,
question,
please.
I think I should have, okay, shelved that for your class test. Okay, so you said it's well made or I should come again. So at this point, you are in a comfortable lead. So here you don't use your calculator. So you use your simplification technique. So times 5, times 4, times 1. I think you can continue. Is that not it? So times 2 factorial, just to save time, all over. Okay. Okay, so Amma.
Sir, please, why is the repetition of the two not affecting the question?
Why
The
is
answer.
what?
The repetition of the two not affecting the answer.
Why is it not affecting the answer?
Because they said we should have 7-digit numbers, different 7-digit numbers, but 2 of them are.
Mhm. This one is not math problem, or it's English problem. Okay, do you see anything wrong with the solution that we presented? If yes, then how would you have presented yours so that we know what you have in your head?
So no, the answer is right.
Mhm,
Is the question.
mhm.
Yes.
Okay. All right. If you were supposed to deal with it your usual way, okay, I hope you are with me. If we are supposed to deal with it your usual way, which is you building your blocks or using your dashes. Okay, let's see what will come out of that. Okay, which maybe someone, assuming you were supposed to use dashes, how would you explain that?
Please, I don't get your question.
No, you are using dashes, 7 dashes. I hope you are with me. 1, 2, 3, 4, 5, 6, 7. So I want to explain from the basic part. I mean, from this one, we realize that we could use the formula. Is that not it?
Yes, please.
Okay, well then the formula comes from the basis, which is what we are doing today. Okay, but what I wanted to do actually is to use the formula, then ask you to go and use the normal way, okay, the basic way, to see whether we end up getting exactly what we have here. Okay, so this is what we have. Okay, okay, so I don't know whether I should give this one. Okay, let me hold on. Do whatever that I need to do. Okay, if I have time, I will come back. Other than that, I'll give it to you as an assignment. Is that okay? So hold on, I will come back to this. Okay, but if you picture the situation carefully, you see that it has been taken care of. Okay, I will come to, if you picture it carefully, okay, as smart as you are, you know that, okay, the situation has been taken care of. Your whatever that you have here has been taken care of by what is here in the denominator. Okay, maybe you have eyes, but you can't see. Don't worry, we will get there. Okay, I will definitely address it. Don't worry at all. Or my point is you can address that. Okay, so that's the more reason why I'm a little reluctant in doing it for you. So let's move on. Okay, when we get to a point, I believe maybe you will be well informed to deal with this. Let me check. Okay, wow, I have less than, I have some few minutes left. Okay, wow. Okay, so if I don't take it, I will finish this. Okay, so now let's go. Don't worry, if you don't finish, maybe another lesson will be recorded and sent to you. Okay, so let's see this one. As for this, we can continue. We have no issues. Okay, so let's go.
Sir, please 2520.
Okay, so which one is the answer?
Yes, please.
No, I'm interested in this. As for this one, I know it's very easy. You can get it. So we are done with this. We are coming to the 15. So let's see, let's extract our digits first. So giving, okay, instead of writing digits, I can just write 1. I know that what I have there are digits. Okay, 2, okay, 3, okay, 4, okay, 5. And here, listen and listen attentively. Okay, so let's read the question. How many numbers greater than 3,000 can be formed using the digits 1, 2, 3, 4, 5 without repetition of digits? So this is very clear. That information has been given directly. Am I right?
Yes, please.
And we are looking for numbers greater than what? 3,000. So if for nothing at all, that's what we are going to do. Okay, number of ways. Okay, will be equal to. Okay, so here, this is what you need to do. Okay, if your number must be, you've been given how many digits?
5.
5. Okay, so if can you have a 1-digit number that will be greater than 3,000? 2-digit number that will be greater than 3,000?
No.
Okay, 3-digit number that will be greater than 3,000?
No.
Okay, 4-digit number that will be greater than 3,000?
Yes.
No.
I heard yes, I heard no. Which is which?
Yes.
I'm going to ask again. Can you get a 4-digit number that is greater than 3,000? Did you say yes?
Yes.
Okay, very good. Okay, the person's network has issues. Okay, so please, this is how you need to approach what we have there.
Yes.
Okay, so it means how many digits have you been given?
Yes.
Okay, I am going to say that if, you are going to get a number greater than 3,000, then you need to take note, since you'll be giving a 5 digits, you need to get a 4-digit number or a 5-digit number. You won't get a 3-digit number. You get it?
Yes, please.
I hope you are with
Yes.
me.
Yes, sir.
Okay, very good. Okay, so now this one, we are handling it from the basics, how we picture the situation, how we visualize the sort of numbers that we are dealing with. Okay, so take notes. I'm going to write. If you have issues, let me know. Okay, so here we go with the first one. So I am going to say that if you are dealing with what, let me put it this way. Okay, so I'm going to look at the 4-digit number. Is that okay? So let's look at the 4-digit number, then we come to the 5-digit number. Is that clear?
Yes, please.
Okay, so the 4-digit number I am going to have, so I will have two possible ways. So two possibilities. So the 4 digits, so 1, 4 positions. Okay, then plus, we'll come to the 5 digits, which will be 1, 2, 3, 4, 5. I hope you are following my professors.
Yes.
Okay, very good. Now, let's focus on the 4-digit number. Okay, so the 4-digit number, and please take notes, okay, you now know that you are supposed to have, you can have a 4-digit number which will be greater than, 3,000, and equally a 5-digit number. So for the 4-digit number, this is what you are going to do. So if you are dealing with what a 4-digit number, and your number must be greater than 3,000, then you should know, okay, that number will start with, which of the digits here? Can I have a number greater than 3,000, a 4-digit number greater than 3,000, starting with 1?
No, please.
Okay, starting with 2.
No, please.
Starting with 3.
Yes.
Starting with 4.
Yes, please.
Starting with 5.
Yes.
Okay, so it means your first position here, which is your first digit, okay, will have how many ways of filling it?
3.
3. I hope you are following my professors. Okay, so that's why I said whatever we are going to do today depends on our level of critical thinking and analysis, how we can visualize, concepts, and situations. Okay, but it's not difficult. So in this case, I know that if I'm dealing with a 4-digit number, any 4-digit number greater than what? 3,000, will either start from 3, 4, or 5. So it means I will have 3 ways here. All correct.
Yes, sir.
Okay, we know that repetition of digits is not allowed. Is that not it?
Yes.
Okay, though you have, okay, 3 here, how many digits do you put here?
1.
1, is that not it? So assuming maybe this digit was 3, it was 4, it was 5, but let me assume it is 5. If it is 5, then it means here 5 is not available for selection. Am I right? Okay,
Yes,
however,
sir.
this time round, okay, this second position, we can, okay, can be 1, can be 2. The 1 and 2 that we ignored can occupy this position now. Is that clear? It is only the first position that the 1 and 2 cannot occupy. Is that clear?
Yes.
Okay, so what will be the number of ways here?
4.
4, very good. Okay, so now after that, okay, going forward, what are we going to get? The next one, repetition is not allowed. So it will reduce by 1, you get it?
Yes.
Okay, so now it will reduce by 1. The next one also reduce by 1. Alpha.
Yes, sir.
Okay, so we are going to use the same concept, okay, to deal with what? The 5 what digit what numbers. That will be greater than 3,000. So in the case of what? The 5, okay, what do you call it? Digit numbers. Are you with me? If you are dealing with a 5-digit number greater than what? 3,000, can your first number be 1?
No.
Can it be 1?
Yes.
Did I hear no or yes?
Yes, please.
Yes or no?
Yes.
Yes. You can start with 1. Any 5-digit number, okay, will be greater than, automatically will be greater than what? 3,000. I hope you get the point.
Yes.
So it means for the 5-digit numbers, okay, all the digits that you have here, you can start with it. Is that clear?
Yes, please.
Okay, so in this case, we are going to get 5 ways here. Okay, so once you filled the first one, you know repetition is not allowed. So our work is going to be easy. So let's continue. So this will give us, so if any
4.
of them, okay, is here, it is not available. So that will give me 4. Any number that is here will equally not be available. So it will be 3.
3.
Any number which is here will not be available. So it will reduce by 1. So I will get what? 2. Any number which is will not be, so this will give me 1. All correct.
Yes, sir.
Okay, so at this point, okay, we are done. So what we need to do is this is equal to, we multiply the whole of this numbers. I'm waiting. Then come and multiply this one too. So I'm waiting for the values. Then we'll draw our final conclusion. In any case, therefore, is there. So I'm waiting.
70.
That is 72.
72,
It's 120.
120. Okay, so that will give us 192.
Yes, please.
192 ways. Safa is the explanation. You can see that it's technical, but break it down. Okay, try to get your objective equation. The objective equation is what we had here. Okay, this one plus that, that's our objective equation where we'll fill in. So if you have a 5 digits, okay, and you are told that you've been given 5 digits and you are looking for a number greater than 3,000, obviously. So this one, I can change it. Let me see. Let me look at the time. Okay, it's almost time. Let me look at the next question. Okay, so this one, okay, I think it's similar. I will do one for you. Maybe let's do the 16 if you have time, then I'll say whatever. Then after that, I think the rest you should be able to deal with it. Yeah, that would be, okay, the last question. Then I know that list. Okay, I've attained my objective for today. So this one, let's see. Question 16 is similar to what we just did. How many 3-digit number can be formed using the digits? Okay, 3, 2, so this is what we have. So given we are interested in the digits. So giving 2, 3, okay, 5, okay, 7, okay, 8. All right. So if the number, okay, so this is the conditional, look at the constraints. Okay, so if the number is odd and no digit is repeated, is that clear?
Yes, please.
Okay, very good. There was one question that I think we did only the A.
Yes, please.
What I wanted you to know, they didn't come in. Okay, in any way, let me quickly explain. You know, this is similar to what we have done. We said next to each other. So it's the same as you box this one, you take this one, you put it in brackets or circle it as one. So it's just like the together situation. They must be together. You know how to deal with that, is that not it? So in that case, you put, okay, you write all the digits and put, what do you call it? Your 137 in a circle. You consider that as a unit. Get your arrangement and later come and find the number of ways of arranging the 137, which will give you 3 factorial. Is that clear? Okay, if I've done that, okay, by doing whatever that I'm going to do there, okay, to help you deal with what? The C. So let me do that because that one is also, okay, about odd numbers. So this is it. Okay, so in this case, I'm looking for number of ways. Okay, so this will be equal to, now we said we are looking for a 3-digit number. So 3 positions to fill. 1, okay, 2, 3. Is my point well made?
Yes, please.
Okay, now, if you have a 3-digit number or any number which is odd, how do you determine that the number will be odd? Anytime I give you any number, how are you able to, especially if the number is more than, okay, it's 2 or more digits? Okay, how do you determine that the number, okay, is odd?
The number cannot be divisible by 2 exactly.
Okay, so yes, but there is something that you usually use. Okay, if let's say I give you 22 and 21, okay, you are able to easily identify this one as odd. Why?
Because 1 is an odd number.
Yes, what is here? The last digit. Is that
The
clear?
last,
So if it will be odd or not, it is dependent on the last digit. Is my point well made?
yes, sir.
Okay, so if your any number which is odd, its last digit must be odd, true or false?
True.
True. Okay, so if the number must be odd, I have a 3-digit number that must be odd, then it means my last digit here must be odd. So the digits that I have available, okay, how many of them do I have to be odd?
3.
3, which is 3, 5, and 7. Is that clear?
Yes,
So it
sir.
means I will have how many ways of filling this space?
3 ways.
3. Okay. It can be occupied by 3. It can be occupied by, okay, 5. It can be occupied by 7. I hope you are following my professors.
Yes, sir.
Okay, good. So this will be 3. Now, you can see that you have 3 here, but you obviously know that one of them, okay, is here. Only one of them is here. So now we move. Repetition is not allowed. So assuming maybe this was, okay, 5. It means 5 is not available to select to get my first what number or digit. Is that not it? Because no digit is repeated. Is that clear?
Yes, please.
Repetition is not allowed. So my first position here, how many ways can I deal with this? Fill this space.
4 ways.
4, which will be what? Okay, if 5 is what is here, it will be 2, 3, 7, and 8. So this will give us what? 4 ways. It's not allowed, so this will give us, the next one will give us 3. Afa?
Yes, please.
Okay, so at this point, the rest will be a calculator work. Is my point well made?
Yes, please.
Okay, so now this is what we are going to get. So give me your final answer. 12 times 3, is that not it?
Yes, please.
Okay, which will give us
36.
36 ways. Afa? Wow, our time is up. Okay, so I think this one I will briefly explain. How many odd numbers, this can be formed from this, without repetition. So take note, this is quite different. You can see anytime you are carrying out an arrangement and you are told to find numbers, form numbers, and the digits that you are supposed to use to form the number involve 0. No, that's by inference. Your first digit cannot be 0 because in numbers, we don't start with what? Our first digit being 0. So indirectly, there is, a constraint on your 0 for your first position. Is that clear?
Yes, sir.
Okay, so that is basically the difference. So when you are failing, you know the first one, here we said it should be odd. It should be odd. When you are considering the odd situation, the last must be what? Must be odd. So it will be 1, then 3. So the last position, that we have here in terms of your 4 digits, will be occupied by either 1 or 3. So 2 ways. But when you come to your first position, you will not have 0 available for selection. Is that clear? Just as one of the numbers, the odd numbers that you put, in the last position, which is the 4th position or the 4th place, is not available for selection. Your 0 will also not be available for selection for the first, digits. So that is going to give you how many possible ways? It will be 3. So 3 ways of putting, or filling your first space. Is that clear?
Yes.
Okay, so I think my point is well made. Is my point well made?
Please come again.
Okay, so I said, 4 digits. And we are saying that the first one, that you did here, this one, because we are dealing with odd, remember, odd numbers. So odd. So this, will be the last position will be occupied by an odd number or an odd digit, if I'm supposed to put it that way. And the odd digits here, we said, remember the odd is here. So we are looking at the 4. Then we come to the 5. So 5 will be 1, 2, 3, 4, 5. Is that clear? So I will explain only the 4. Without understanding, you go and use it to do the 5. So then you add your result. For the 4, we said if the number will be odd, the last digits that I have here, the last position will be occupied by the digits, which is odd, and that will be 1 and 3. So 1 and 3 will be here. So I have 2 ways. Is that clear? 1 or 3.
Yes.
Is that clear? But you can see that repetition is not allowed. This position has only 1 of the digits there. So assuming it was 1, which is here, if I'm going to my first one, which is my first position, I know that my first position, 1 is not available for selection because 1 is here. Is that not it?
Yes, sir.
So 1 is not available for selection, assuming 1 was here. If it is 3, it is 3 that will not be available. So 1 of them will not be available. Then you come to your first digit here. Equally, for it to be a number, it cannot be 0. I hope you are with me.
Yes, sir.
So it means equally 0 is not available for the first position. So for the first position, we have 2, 3, 4. So it means I will have 3, ways of filling that. Is that clear?
Yes, sir.
Now I come to the next one. Okay, so the next one, obviously, you know that this time around, 0 will be available for selection. Is that not it?
Yes, sir.
Okay, so at the normal circumstance, let's shelve 0. If you had shelved 0 and you move, repetition is not allowed, what will happen? This will reduce to 2. Is that not it?
Yes.
But because this time around, you can what? You can bring in the 0. The value now becomes what? 3. Is that clear?
Yes, please.
Then the next one becomes which value?
2.
2, as simple as that. So I think with this explanation, you should be able to do this. There's this one, 2, this will be 2. Okay, you know, how to proceed from here as well. So if this is what the next one, you know it will be, then so this one will give you 3, again, 3, 2, 1. Am I right?
Yes.
Okay, so you multiply each of them, then you add, then you get your result. So far.
Yes, sir.
Okay, so those of you with your understanding not perfect, don't be too worried. Get the video, take your time, and take notes of all that I've said. Okay, especially the one that I said you could relate. Okay, therefore, use the normal way to deal with it. Okay, unless you're assuming you've not been taught the basic way, and you want to use our normal way, which is the formula way. Go the formula route and see whether you end up getting the same result. Because by then, you will know your answer here. If you have any other issue, okay, you bring it up in our next meeting for discussion. Is that clear? But I know that if you follow keenly whatever that I've said and whatever that we've done so far, okay, what we have here will be trivial. Okay, you trample that, okay, under your feet. Okay, so thank you very much, okay, for a wonderful session once again. Okay, God bless us all. At this point, okay, once again, thank you for everything. Okay, so bye-bye.